All right, guys and gals, so today we're talking about percent composition. This is going to be a pretty short lesson, but it is important. We're getting into some real practical chemistry here, and so this is an important foundation for the next few steps, if you will. And so, percent composition. Um, what is the percent composition of water? Well, here's the thing. Percent composition can be defined in many ways. Like, for example, in this water molecule, there are 2 hydrogens and 1 oxygen. And so some people might say that water is 66% hydrogen and 33% oxygen, which would technically be correct because there's 2/3 hydrogen atoms and 1/3 oxygen atom. And so that is a correct assumption and a correct analysis of water. However, in chemistry, we need to know percents by masses because we can't get in there and count the number of hydrogens and oxygens in a molecule, but we can weigh them. Remember, the mole allows us to weigh atoms. And so we're going to look at it a little bit different. So we're going to do our percent composition according to the mass of the atoms, not the number of atoms. And what that will eventually allow us to do is we'll take that mass and we will convert that to the number of atoms, because that's what mass lets us do. We can go from mass to moles to numbers. And what we're really going to be looking for is ratios. But anyway, I'm getting ahead of myself a little bit here. And so just remember that when we do percent composition, we do percent composition by mass, not by number of atoms. And so percent composition, here's a simple little formula. You know what percentages are. Percentages are a part over the whole. And so what part is the element over the compound as a whole times 100 to get us to the percentages. And so we're going to do 2 simple little examples here, and then I'll let you go on your way. And so we'll look at the percent composition of water. Let's take a look at that one first. There's your little formula, the mass of the element divided by the mass of the compound. That's what we need to know. And we need to do that for each component of the compound. And so each of our components here are hydrogen and oxygen. And so we will do the percent hydrogen, and we'll do the percent oxygen. And so we have 2 hydrogens. And so if we look at our, where did my periodic table go? So if we look at our periodic table for hydrogen, looking at the hydrogen atom, we have a mass of 1.008. Again, I'm going to do 1.079 because that's what's in my head. I just use it. It's habit. I don't care if you use 1.0079 or 1.008. Oxygen right here, 15.999 would be the 2 masses that we are looking for. And so, all right, and so back to this page. So we're looking at the percent hydrogen and the percent oxygen. We have just figured out that the hydrogen's mass is 1.079 for 1 hydrogen, and oxygen is 15.999. And so we'll take 2 times hydrogen, so 2 times 1.0079, that's going to give you 2.0158, and so that is the mass of the element, so 2.0158, and the oxygen is 15.999. Now those are the masses of the elements, so this is the mass of that element, hydrogen. This is the mass, and we have 2 hydrogens. This is the mass of that element, oxygen. We only have 1. And then we need the mass of the compound. So you just add these 2 masses, the 2.0158 and the 15.999 together. And when you add those together, you get 18.0148, and that's the mass of the compound. So we put that underneath both of these, 18.0148 and 18.0148. We'll multiply by 100 to get into the percentages. And what you get here is you get, for the hydrogen, you get 11.19%. And for the oxygen, you get the 88.81%. And these should add up to 100%. You can double check your answers by doing that, right? Because all percentages must equal 100. And so that is your answer for the first one. That's pretty simple, pretty straightforward. They obviously can get more complicated with more complicated compounds. So let's do one that's a little more complicated. Actually, I want you to try this one on your own first. So if you want to go ahead and pause the video and attempt this, and then unpause me in a little bit and see if you got the right answer. And so I'm going to continue, though. We have aluminum nitrate here. So we have 1 aluminum. We have, remember this 3 here gets distributed to everything inside the parentheses. So we have 3 nitrogens and we have 9 oxygens. So let's go find our masses of aluminum, nitrogens, and oxygens on our periodic table. And so if you look at your aluminum, which is going to be right here, 26.982 is the mass of aluminum. And then nitrate, or the nitrogen of nitrate is right here, 14.007, and the oxygen, 15.999. You're probably starting to memorize some of these numbers we're using a lot. That's actually a good thing. If you have them in your head now, it'll make you a lot quicker. So anyway, so there's the 3 masses we need. So let's go back. And so we're going to do the 3 parts. So we will have the percent aluminum, we'll have the percent nitrogen, and we will have the percent oxygen. And so aluminum had a mass of 26.982. So that's the part of aluminum, 26, and there's only one of them, 982. So there's only one aluminum here, right? There's a 1 there, subscript. We have 3 nitrogens. So if you look at your nitrogen, there are 3 times, and its mass was 14.007. Let's multiply 3 times 14.07. We get a total nitrogen mass of 42.021. So that's the mass of our nitrogen portion, 42.021. And then this 3 gets distributed there, so we have 9 oxygens. So 9 times the mass of 1 oxygen is 15.999, and that gives you 143.991. So that is the mass of the oxygen, 143.991. All right, so those are our 3 parts. Now what do you do to get the whole, the mass of the whole compound? You just add these 3 parts together. You add those 3 parts together, and you get, I'm going to put right down here, you get 212.994. So take that 212.994 and put it underneath each of these. 212.994, 212.994. Now we're going to multiply them all by 100 to get our percentages. And 26.982 divided by 212.994 gives you 12.67%. And the nitrogen, 42.021 divided by 212.994 times 100 gives you 19.73%. And the 143.991 divided by 212.994 gives you 67.60%. So these are your 3 percentages of aluminum nitrate by mass. So the percent by mass of aluminum nitrate. So that is how you do that example. So basically every percent composition problem where you're just trying to figure out the percent composition is basically the same. Find the masses of the parts, take the mass on the table times how many of those atoms you have. Find each part's mass, add up the masses to get basically the molar mass of the compound, the total mass of the compound. Divide each part by the total and multiply by 100, and you'll get your percentages. You can check your answers very easily because if you add those up, you should get 100%. Now, if you get 99.99% or 100.01%, that's fine, no problem at all. Significant digits, just go out 2 decimals on your percent number. That'll be more than enough significant digits. You don't have to go out, 5 or 6 on these. 2 decimal places on your percentages will be more than sufficient for your significant digits on percent compositions. Okay? All right, that's it for today. Short and sweet. See you guys later.